For those of you who are curious, inquisitive, and eager to investigate the world around you, let's investigate an unassuming rock with hidden surprises inside that one might call God's most inspiring rocks, or God's creation, called the Thunderegg.
Look at that.
I see it.
Oh man.
Ooh, there's a big chunk right there.
Oh man.
Ooh, that's pretty.
Wow, that is cool.
That's pretty. That's like a blue, really blue. Oh, that's pretty.
Boy, we will be taking that one.
Yeah.
I want to showcase what might be one of the most intriguing rocks that fascinate even the most non-curious of people. Now, let's get some definitions straight. A nodule is like a thunderegg that started out with a cavity or hollow space inside of solidified lava-like basalt or rhyolite and was filled up with soupy liquid heavily saturated with silica, calcite, or opal, and depending on the crystalline structure of that silica, it would become quartz, agate, chalcedony, or jasper, and it could be a mixture of all four. So a thunderegg is a nodule. A geode is similar to a thunderegg that starts out as a cavity but never gets completely filled in with crystals and can have similar mineral structure in it as a nodule. As I understand it, both nodules and geodes can be either formed in volcanic environment, meaning lava or hydrothermal activity, or a sedimentary environment. I believe most were formed from lava volcanic environment from lava. Now, if you are where I am from, most of your geodes or nodules can be found in or around basalt or rhyolite, which are both volcanic rocks. You will find more of them around rhyolite flows because rhyolite has a lot more silica in it than basalt. In Catastrophism County, Washington, we find a lot of these nodules and geodes in the Tiana Way Formation, which is a basalt flow from basalt dikes intruding the Sedimentary Formation. Now, to impress and inspire you, this Tiana Way basalt flow is approximately 5,000 feet thick, sitting on top of approximately 28,000 feet thick of sedimentary layers called the Sedimentary Formation. Just one formation, just this one formation, dwarfs the height of the Grand Canyon at least 3 times.
That's where I'm going.
We almost, I don't recall even seeing any amethyst came out of there. Mostly the clear quartz crystals initially, then they had a second growth of calcite on top of the quartz crystals. So you'll get these nice clear ones and then these white calcites on top of those.
Okay. So those are geodes.
Yeah.
Up there.
And this is about the end of the geodes. Everything else going further up the road now is going to turn into agate veins, thundereggs way up above. And,
okay.
if
Well, we'll get out here then. Okay.
But this hillside has been dug for years here, and everything from the road on up above here, if you just start digging a hole, you're going to find broken geode pieces. You know,
Yeah. Okay.
We find these round rocks in the Tiana Way because this basalt flow is higher in silica than your average basalt flow. This is also where we find the Ellensburg blue agate. Oregon is known worldwide for its impressive round rocks that we find in and around volcanic rhyolite flows, very high in silica. In fact, Smith Rock, which mainline geologists are calling a supervolcano, we find some of the finest thundereggs in the world just 38 miles south of Smith Rock. Now, let's clarify one thing. No one knows for sure how these rounded rocks were made. There are several theories as to how they were formed and variations to each theory. But what is really exciting is that they are believed to be made through underwater lava volcanic action, giving support to catastrophism. Some of these rounded rocks were made in sedimentary layers, were also probably made underwater by hydrothermal activity. The most common theory is underwater volcanic eruptions spewing out lava, forming CO2 gas bubbles and cooling very quickly from the outside layer, creating pressure on the inside, pushing molten lava rock out from the inside and hardening into a ball, so liquid like water heavily saturated with minerals will enter into the volcanic ball cavity. Then in a short period of time, the minerals will precipitate out of liquid, solidifying into what looks like crystals. You can actually grow your own crystals at home and see that it does not take millions of years to do it. We simply use salt by adding a large volume amount of salt into a beaker of water, and we got rock salt in just a matter of few days. I explored a gold mine in Kellogg, Idaho, where it took only about 100 years to grow the mineral smithsonite on the mine walls. Now that bit of information is censored out of mainline science. I have hunted for thundereggs mostly in Wyoming, Washington, and Oregon, and no matter where you look for them, they all have their own individual characteristics on the inside. You never know what amazing beauty you will uncover in those round rocks. If rocks could talk, what would they tell us? Well, today I'm going to showcase thundereggs, geodes, and nodules here at Mark's Academy of Science and the Tri-Cities Creation Science Club.
Whoa, look at that.
There are several theories about the formation of thundereggs and geodes and nodules, and I'm going to talk about the mainline theories about how they are created. You know, that's one of the neat things about geology, is that even if you're wrong, nobody's going to really know the difference, because none of us were here in the past when these types of rocks were being formed. And so really, in a sense, one theory is almost as good as another. But the mainline theory is this, is that there were volcanoes under the ocean spewing out lava, lava's made bubbles, and liquid heavily saturated with minerals got into the lava bubble, and the minerals, they precipitated out of the solution, creating these beautiful, what we now call thundereggs or nodules. So what's the difference between a nodule and a geode? A geode is a lava bubble that has a cavity inside of it that never got completely filled up with minerals. So here's a nodule. A nodule is like a lava bubble, for example, that got filled up with liquid that was heavily saturated with minerals. And you can see the different layers of minerals in this nodule. And I've got lots of nodules that are like this, and they're actually, they're more or less called thundereggs. I like to call them God's wonder eggs, because you never know what you're gonna find in one when you cut them open. And so see, when you find them, they're like this. We found this one, actually it's my wife that found this one in Oregon, and when you cut them open, you never know what you're gonna find. And there's no two thundereggs that are alike. Every one of them is different, just like every snowflake is different. Every fingerprint is different on a human being. There's no two fingerprints that are the same, no two DNA sequences or prints that are the same, no two thundereggs that are the same, and no two snowflakes that are the same. It's amazing, God's creation. And one of the amazing things is that we can kind of tell how these thundereggs were filled up, because if you look at this real closely, it looks like there's a pinhole here and there's a pinhole right here. Now hopefully you can see that on the video, and you can kind of tell that liquid heavily saturated in minerals went through this hole and filled up the cavity here, and the same thing right here. There's like a little pinhole right here. And so liquid filled in this cavity, filled it all up, and then the minerals precipitated out of the liquid and solidified, and that's why we have these beautiful mineral-like layers in there. Now, an evolutionist might tell you, well, you know, it took tens of thousands of years, maybe even millions of years, they will say, to create one of these thundereggs or nodules. Now, not so fast, people. That's not necessarily true. You know, there's good evidence to show that these thundereggs or nodules were created in a short period of time, not a long period of time. And one way we know that is because these mineral layers are stratified. You know, it's just like you go to the Grand Canyon, you see the sedimentary layers. They're all laid down like pancakes, they're all stratified. These mineral layers are all laid down like pancakes. Now, I would think, you know, it'd be kind of like common sense that if it took millions of years for these thundereggs to form, where it took a long time for the minerals to precipitate out of the liquid, you would not see these perfect like layers in here. It would only make sense if the minerals precipitated out of liquid quickly, not over a long time, over tens of thousands of years. You probably wouldn't have anything then. Now, we know for a fact that there's a gold mine in Kellogg, Idaho, where smithsonite is growing on the mine walls in about 100 years. So it doesn't take millions of years for a rock to form, or a thunderegg to form, for minerals to form. It doesn't take millions of years. Now, what's inside of these thundereggs is mostly silica dioxide. And then, of course, it depends on the crystal structure, and from that you can get chalcedony, agate, calcite, which is not silica at all, or you can get opal. You can get these different types of minerals growing inside of a nodule or even a geode. Here's a lava bubble that wanted to become a geode, and you can see the cavity in here, but it never got filled up. So this is a great big lava bubble, and I've seen one that was as big as a semi-truck in Oregon at the Lucky Strike mine. Here's another geode that was found in Brazil. We call this a Brazilian agate. And you'll notice the cavity in there, and then we have silica in here, and we have chalcedony around it, and you might call this lava bubble a frame. So it's a frame that encapsulates all these beautiful minerals that make up these agates and thundereggs and geodes and nodules, and you know, it's really cool. I found this thunderegg in Oregon. And of course, like I say, you never know what you're going to find inside. And look at that. Isn't that amazing? Right there. Yeah, you can see all the stratified layers, all the minerals that make up the thunderegg. And you just never know what you're going to get inside. And even the most non-curious people find these to be quite fascinating. You know, you're walking along and you find something like this, and you might be wondering, well, how would I even know that this is a thunderegg? I mean, it looks like any other rock. Well, actually, it doesn't. Your eyes just have to get adjusted to it. So to me, a thunderegg or a geode, before you cut it open, to me, they don't look like just any other rock. In fact, when you look at these, first of all, they're usually rounded, and it's like they have dimples or zits, bumps on the rock. Is what I like to call them. I like to call them like, you have like, well, warts, for example. You got like, warts growing on the sides of the rock, and that's a telltale sign that you have a thunderegg or a geode or nodule. And the thing is, people, is that these are made mostly all in about the same way. The mainline theory is that there was volcanoes going off under the ocean waters, spewing out lava, creating these lava bubbles by way of gas expansion, creating the bubbles. And then once the bubble is formed, then there's like a little pinhole or something where the water that is heavily saturated with minerals can get into the bubble, and then the minerals precipitate out of the water, and then it creates these beautiful formations in the egg, in the thunderegg or geode or nodule. Now, here's kind of an exception to the rule. Now, we do find some nodules that are growing in sedimentary layers due to a lot of water. So here is a geode that's got all kinds of real beautiful crystals in it, and this was formed in sedimentary layers, not as a result of volcanism or volcanoes or lava, not that kind of stuff. So this was when there was some type of a bubble in the sedimentary layers, and water heavily laden in minerals got inside of this bubble of dirt, and the minerals precipitated out and created these beautiful geodes. Now here's one of my favorite type of thundereggs. Now this was found in central Washington between Cle Elum and Leavenworth, Washington. And this is kind of a geode and a nodule all put together in one rock. And then you can see the stratified layers right here. Now when we see these stratified pancake-like mineral layers, that is evidence that these rocks were formed quickly over a short period of time, not over a long period of time. Now I have really good memories of finding this rock. I was out in the high desert in Oregon, and I was hiking up to a cave that nobody has found that I know of. So I'm hiking up to this really cool cave, and it ended up being a double cave. It went back quite a ways, and before I got in the cave, I just saw this rock sitting on the ground, and I said to myself, well, you know what, that's a thunderegg. And so, this is a big one. This guy, he weighs 10, 15 pounds. And so I took him home and had it cut open, and here you go. Look at that. That's amazing. And then once again, you can kind of theorize that there's the pinhole where the liquid got into the bubble right here. Oh, and especially right here. Here you can really see it. It looks to me like there was a hole in the bubble, and this is strong evidence that these rocks were formed underwater, not above ground, because somehow these crystals, these minerals, had to get into the bubble. And the only way to do that is if these are being formed underwater. So that's a pretty good theory for not ever seeing how these were formed. So I would say that these were formed out of catastrophism during Noah's flood, when the whole earth was covered by water. That's a far better theory than the evolutionists, because the evolutionists, everything to them, it has to be done over millions of years. It's boring, okay? And so you can see the hole here where theoretically speaking, the water got into the bubble that was heavily saturated with minerals, and then the minerals precipitated out as the liquid dried up in here, and then you have these beautiful mineral layers, just one after another, like pancakes. So that's evidence of rapid rock forming. So now here's one of my favorites. This is one I found in Central Oregon out in the high desert, and we got a lot going on in this rock. Now this is like part nodule and part geode. So this would be the Thunderegg portion. This would be the geode portion right here where you have the cavity, and lo and behold, but at the very bottom we have mossy agate. So we have mossy agate up here, we have silica, chalcedony, that kind of stuff going on. And so this guy, he's a big one. This is only half of him. I got the other half sitting here on the table. And so once again, you can kind of see where there was a hole here in the bubble where liquid heavily saturated with minerals got in here, and the minerals, they solidified, and once again we see the beautiful colors, the beautiful layers of different minerals creating the different colors. Here's another one that I found in Central Oregon in the high desert, and as I was digging it out of the ground, this egg just broke open, and voila, that's what we got. It's almost like a jewelry box. I mean, if you could put hinges on it, you could make this into a jewelry box. So yeah, you never know what you're going to find. Now here's another amazing egg. You can see for scale the size of my hand. Okay, and you never, like I said, you never know what you're going to find. And the guy that cut this open for me, he says, wow, I've never seen anything like that before. This is truly an amazing Thunderegg, or now what do you call this? It's called a nodule, right? Okay, so hopefully we can get that clear. That's what it looks like inside. It's got blue and gray, white, all kinds of things going on inside of there. Here's the other one. Then I found this geode on Red Top between Cle Elum and Leavenworth, Washington, and I put hydrochloric acid on this rock. Turns out this is calcite in there. Now, here's something that's really interesting. Considering that this is calcite, this is a geode, this was made out of lava. This was found in the Tiana Way lava flows. So with that in mind, about that geode that I just showed you that was full of calcite, well, here's another rock that's got calcite. Now the host rock is the Tiana Way basalt flows, which is 5,000 feet deep. 5,000 feet deep, that's right. There was a lava flow here in the state of Washington, central Washington, that was high in silica, that had a flow of 5,000 feet deep. Now, that's where we find our Ellensburg blue agates, our geodes, our thundereggs, our nodules, all in that lava flow, because that lava flow was high in silica, higher than the Columbia River basalt flows that don't have as much silica, so you don't find as many geodes or thundereggs in those type of flows. But here we find calcite on top of Tiana Way basalt host rock. Now, this is really cool, because in calcite like this, over there in central Washington, sometimes we find wire gold. Now, wire gold is the purest form of gold. Now, sometimes, you can be in a stream and you might pull out a gold nugget. If you're really fortunate, you'll find a gold nugget. Well, that gold nugget was at one time wire gold. And so wire gold gets eroded out of its host rock, and in this case, it would be calcite. It tumbles down into a stream and then tumbles in the stream, and then it turns into a nugget. And so this area where we're finding a lot of thundereggs, geodes, and nodules between Cle Elum and Leavenworth, Washington, is a very amazing, it's a very special and unique area. And so here is another type of thunderegg that we find in the Tiana Way basalt flows. And that's because those basalt flows are high in silica. And so we find a lot of these kinds of thundereggs. So here's a geode that we find in the Tiana Way basalt flows. And so, you know, you can kind of picture in your mind at one time, this was a complete ball, not a perfectly round ball, but it was complete. And something broke it open, and voila, this is what we find in it. Now, I've not taken hydrochloric acid to this, so I don't know if this is silica or if this is calcite. Now, this is one of my favorite thundereggs that I have found in Central Oregon. Now, you just take a look at that. Hopefully, that will come through. Because you can see right here, there's some really clear and shapely crystals inside of that thunderegg. And, you know, you kind of look at this as being the frame, and this is the lava bubble right here, and you can see where the liquid may have entered into the bubble on these two sides right here. Now, here you have opal, and here you have silica in here. And depending on the crystalline structure, will make different shapes and forms inside of the bubble. So, in conclusion, we have learned about geodes and nodules. We've learned that thundereggs are nodules. Geodes are a cavity that were never completely filled in, like this one. Most of your geodes and nodules were created through lava flows, which may have come from a volcano. Some of the more mainline theory now is that a lot of these types of rocks were created in oceans. Now, we as creation scientists, we would say, okay, that was the flood waters of Noah, but the secular evolutionists, they will say that this happened in ocean waters where volcanoes were erupting, spewing out lava. The lava formed bubbles due to gas creating a bubble, and then liquid that was heavily saturated with minerals got into the bubble, and then the minerals precipitated out of that liquid, and the liquid dried up, and voila, you've got these beautiful thundereggs or geodes or nodules. We as creation scientists, now we would agree with that, except we believe that the whole earth was covered with a universal flood. When you look at the scientific evidence, it's a no-brainer, and you almost have to be dumb on purpose not to believe that there was a universal flood. Thousands of years ago, which was Earth's greatest catastrophe that created all of these beautiful rocks that you see here, even the fossils that we see. And that's going to be another documentary.